Assalamu alaikum everyone. This is another proof on circle theorems, and this theorem is the angle between a tangent and a chord is equal to the angle in the alternate segment. So in order to prove this circle theorem, we're going to look at this diagram here. What we're trying to do here is we're going to try and prove that this angle over here between the tangent, the blue tangent, which is over here. Let me give another letter. I'll put a point here and let's call this point D here. So we're trying to prove that the angle between the tangent and the chord is equal to the angle in the alternate segment, which is this angle over here. Alright. Okay, let's see if we can work through this and prove it. So let's get started. So we can start off by saying let angle CBD be x. So we call this angle here x. Okay. Therefore, angle OBD, not therefore, it should just be angle OBD. Angle OBD is equal to 90 degrees, and the reason for this is OB is a radius and BD is the tangent, so radius and tangent meet at 90 degrees. Okay, so what we can say is this angle here is 90 degrees. So what about this angle over here, OBC? Just that bit there. So let's try and work that angle out. So angle OBC would have to be 90 degrees minus x, because up to here, up to that point, the angle has, because the full angle is 90 degrees, this much is x, so this much has to be 90 minus x. Okay, now we look at angle ACB. Angle ACB, which is this angle here, is 90 degrees. Why is that? Well, if we look at it carefully, AOB is a diameter, right? So angle ACB is an angle in a semicircle, and from the previous circle theorems we know that an angle in a semicircle is 90 degrees. So this angle here is 90 degrees. Now we are going to find out the size of angle CAB. So angle CAB, which is this angle here, CAB, will be equal to 180 degrees minus 90 degrees plus 90 minus x. So basically we're looking at this triangle, the three angles of this triangle, so we can add these two up and subtract it from 180 to find this one. And the reason for that is angles in a triangle add up to 180. So that's gonna give us 180 degrees minus, I can simplify this to 180 degrees minus x. When I open the brackets up, it's gonna be 180 degrees minus 180 plus x, which means angle CAB is equal to x degrees, which is the same as our first angle, which was angle CBD. So that's x2 and this is x2. Okay, so this is one of the most confusing circle theorems to picture. So the way I look at it is, if there's a chord and a tangent meeting, so they form an angle in one section of the circle, right? So this is the segment in which the angle is formed. So any angle that starts from one end of the chord, touches the circumference and goes back to the other end of the chord will be the same as this angle. So even if there was an angle that started from here, touched the circumference here, went back to there, that would be x2. Anyway, we'll look at some circle theorem questions later on, but this was the proof for this particular circle theorem, the alternate segment theorem. Thank you for watching, and assalamu alaikum.